Hello friends, सबको नमस्ते. So today in this video we will create a crack image segmentation model using a DeepLabV3 ResNet50. Okay, so let me show you the dataset. This is a dataset and it contains images like this and the mask of them. See the mask. Okay, now this is the Jupyter. This is a weight file. Okay, which is trained on 50 epoch, and this is a Jupyter file which I will explain you, and this is a helping code which I will during explanation I will take help of this code to explain you something. Okay, so let me open this in Jupyter. See, I already opened it. Okay, so this is a library which connect your Google Drive with the Google Colab so that we can easily download the zip file from the Google Drive. Upload the dataset in a Google Drive, copy the link, make sure that it is stick on anyone with the link. Okay, copy the link and just paste it here and keep this part only. You can say this is a unique ID of your dataset which help the G-down library to download the dataset from your Google Drive. Okay, so let me run this. Then run this. Then run this. See the result. First it downloads a zip file, then it's unzip it. See, test train valid. Okay, now these are the libraries which we use for creating the data loader and for the segmentation part and for the training part also. This time we use learning rate scheduler. Okay, now these are the directories of images and masks in the train directory. Let me see that how many images are present. Make sure that during training or before training you make sure that in training directory number of images and number of marks should be same, otherwise during training it will throw an error. Okay, so this is the main part of the whole image segmentation. You can say creating the model and the other thing. What is the main thing in this is that how you have to segment the images, how you have to segment the images when the original image is present and the mask is present. How you have to combine these two images so that we can get the segment images. Okay, so let me explain this whole code. From here. Let me open this. Suppose this is an image, okay, and you have to retrieve, or you can say fetch the red channel, green channel and blue channel. Okay, so how you can get that? You can get that using this image, 3 dots, comma and 0. It will give me the red channel, this will give me the blue green channel, and this will give me the blue channel. Okay, so how see how the values is connected to red, green and blue in the image and numpy array. See, 255 1 2, 255 1 2, 255 3 255, 255 3 255, 128 64 192, 128 64 192. Same for the green and same for the blue. This way you have to fetch the red channel, green channel and blue channel from the image. Even you can see this in this picture. See, it's a 5 by 5 images. Red, you can see red represented by this line, green this, blue and this. This way you have to see you can say see the red, green and blue channel in your image numpy array. Now let's go back to the explanation. See why I'm telling this, because during explanation or during this explaining that function blending of images, you have to make sure that how you have to calculate, or you can say fetch the red and green blue channel from the image, you can say 3D numpy array. Now see, this is a mask. Let this is a mask containing the values 0 to 255, 255. Here 255 and 255 and 255 actor is a, you can say it's a reason where the segmentation has to be performed. Okay. And this is a overlay. What is this overlay? Let me show you. Here overlay is a np0 like of size image. Okay. And its data type is unit 8, np unit uint 8. Okay. So say this is an overlay of size image, and its pixels values is 0. You can say it's a complete black image. Now this this is an image containing some pixels values. Now how we have to get the blended image or a segmented image from the from the image. Okay. Now see, this is alpha. What is the meaning of this alpha? Alpha basically 0.5 is 50% accurate, not accurate, 50% transparency over the segmentation part. We have only one class, cracks. That's why its class ID is 1, and it's 255. It's a yellow color, but I want pink. This time I have to use pink color for this. Okay, so this is a pink color. Now see, this is a mask. I want to change that mask not equals to 0 is equal to 1. Means all the pixels values where there is 255, 125, means all pixels values which is not 0 has will automatically change to 1. Now this when I will use this line where 255 in this mask change to 1. Okay, let me show you the result. See, before mask, after mask. Now object mask, this is nothing. This is, I think this is, this is overlay. You can see this is overlay, a complete black image means 000 value, and its channel R channel green, red channel, green channel, and blue channel is also be 00 pixel. Okay, 00 2D array, you can say. Now we have to change this overlay, means we have to change this overlay according to the, you can say according to change the red part, red channel, green channel, and blue channel of this overlay according to the mask of the image. See this, when we iterate over the class color, first it will give me the class ID and a color. We only have a one class name, cracks, so its class ID will be 1 and color will be pink color. Now this is marks is equal to class ID. What does mean? Means all the area, or you can say all in the mask, all the pixels values where it is 1, it will you have to show the true. Ultimately you can say that when you this line will get executed, class marks basically it's a boolean, you can say variable class mark boolean 2D array. Say this, let me show you the class mask. Class mask is a boolean 2D array, and it's show true only at that place where 1 is there. Okay, that's why class mask is equal to id, means all the places where 1 is there, change that value to true, and it's give me the boolean class mask boolean 2D array. Now we have to iterate according, we have a 3 channels, so range will be 3, and overlay is suppose c is equal to 0. At first iteration c is equal to 0, so first we have to retrieve the channel of the overlay and just pass the boolean class marks to it. What is happening here? See this, when you pass the overlay, you can say a red channel with a class mask, then where there is true, in the class mask, see, one important thing I want to consider, that here when we iterating till here, till this, when we suppose c is equal to 0 for the first iteration, it is a 2D array. Is in this type, it is in 2D array, and class marks is also in a 2D array. So where there is a true in the class marks, that value will change into color C. For the first iteration, color C value will be 255. Say this. Say this. Overlay red channel, all there where is true, it's changed into 255. And same for the green channel, all there is I think so. Let me run it again, because before it is 255, 255, 255 0, but now I had changed it. So see the changes. See, when we talk about the green channel, for the pink color, at color C, when C is equal to 1, its value is 0. That's why it's changed into 0. Now see, for C, as for the blue channel, all the places where true is there, it's changed into 255. What is, why only 255? Because it's color C. When C is equal to 2, color C value will be 255. This way, we change the overlay according to RGB channel. And see, when you combine this red, green, and blue channel, you will get a complete overlay. What is in this overlay, this 255, 250, what is representing? It's representing the portion of the segmentation. The means at particular portion the segmentation has to be performed. That's why we have to use these lines. Okay, this line. After this, we have to use the, we have to create the our blended image, means final image of with the segmentation. How it is created? Let me come back with the world. So this is a channels, this is the overlay. It's already explained you. So this is the image, and these are the green, red channel, green channel, and blue channel of the image. And this is the overlay, red channel, blue, green channel, and blue channel. Let me cross check it. No, this time it should be 00000 at in between for the green, because this time we are using pink color. But I think I have to use yellow color, because this, if I will use pink color, it will be, I have to make so much changes in calculation, which I do not want that this time. So sorry for that. See this. So let me first cross check it, so that you will not get confused what is happening here. See, overlay red channel is 0, 255, 255, 0, 0, 255, 255. When it is yellow, when I am using red, yellow color, okay. Say 255, 0, 0, 255, 0, 255, 128. Sorry, 0 to overlay red channel is 0, 255, 25, 0, 0, 255, 255, 0, 0. Same way for the red, green, and blue channel. You can see that how it's performing. So this way, and same for the image. You can see our image is this. So our red channel will form 255, 00, 255, 0, 255, and 128, 164, 192. See this. 255, 00, 255, 0, 128, 64, 192. This way means our red and green channel, and these are the red, green, blue channel of the image and the overlay. This is a mask. Now, I already told you that during calculations, during the manual calculation, you have to pass the Boolean 2D array. Okay. When I will use this mark 001, it's already give me the Boolean 2D array, and where there is 1 in the mask, it show me true, and other places it show me false. Okay. Always make sure that when you have to use this blended image formula, you have to pass the Boolean 2D array here. Now suppose C is equal to 0. Now C is equal to 0 means red channel. So this is a red channel of image. This is a red channel of overlay. You can also cross check it. and see what is happening here now. Multiply by 1 minus alpha. I already told you the alpha value is 0.5, but 1 minus 0.5 always be 0.5, and 0.5 is actually means 1 divided by 2, so it should be 255 divided by 2, nothing change. Why? Because in boolean 2D array we are passing, it's the places which we have to change is the places where true is there, and it's true where true is there. True is always on a one place where one is there, true will be there. So 110 means 0 divided by 2, nothing happened. But here 1, so 255 divided by 2, 127.5. Here 1, 120 divided by 2, 64. Same for the overlay. See, same for the overlay. Mass is equal to 001 divided by 2. So 255 divided by 2, 127, 25. Then you have to add this. After adding 255 plus 0, 255, 127.5 plus 127.5, 255. This way you get a red channel of the blended image, or you can say the final image. Same way you have to get a green and blue channel. Okay, when you will get the green and blue channel for with the same calculation, you have to make the blended image. See, 255, 255, 127, 127, 255, 127, 127, 255, 0, 255, 255, 0, 255, 191, 64, 192, 191, 64, 192. Same for the green and blue channel. This way, we get a complete blended image over the image with the segmentation part. Okay. See, in this, when we get this overlay red and green blue channel, we basically adding a color. We adding a color on a image, or we can say overlay. When we overlay use with the image formula, color is added to the image, and you already know what is meaning here. Okay, it will give me the final output using this. Now let me go back to the code. I already explained you each part of this. Here the basic difference is, here I am using class mass not equals to 0. What does mean? Means where here class marks give me the boolean 2D array where there is 0, its value will be false and other values will be true. Just pass the class mass, you will get the result of it. So let me run this. Now let me run this to show the result, then I will explain you what is happening there. So see, these are the directories. This is a list of the images presented in the image directory. Figure here represents the entire image. Axis here is basically for the 2D array. Here axis here before using a variable is in a 2D format. Now when we use axis here, it is in a 1D format. And subplots 4x4, figure size 2018. So let me first show you the result, because you will get confused what is I'm saying here. Ax dot shape and skip print ax dot shape. Okay, let me first explain you whole thing, then I will show you the result of that. This is the alpha value, 50% transparency. We only have a cracks and its class id is equal to 1. Now here we are converting. I already told you why we are using this, because I want to convert all the pixels value which is greater than 0 to 1, because it represents that one is a particular reason where the segmentation has to be performed. Now first randomly choose the image file name from the images variable, create an image path, just pass the image directory and image and uh, let me show you one thing more. Here images in a JPG format and mask is in a also in a JPG format, but it's sometimes it's there sometimes there that images extension and and a mask and extension is not same, at that time you have to be very sure that you can change the extension before loading the mask, or you can say before loading the mask during the training time. Okay, how we can get the mask path, OS path, there is no need to change the extension, it's already in a JPG format. But in place, when there is a mask in a PNG format, you have to use just PNG. Here you will get the mask path. Okay, so don't, just for the explanation I'm saying that. Okay, so don't get confused what is happening here. So mask path, we'll get the mask path, or load the image, and load the image in a grayscale, sorry, not grayscale. Here we are loading the mask in a grayscale format because image mask is in a grayscale, and here we are converting the image into a RGB because CB2 read the image in a PGR format. Now we have to convert any non-zero value to 1. Here we are converting. I will tell you what's the reason, what is the value, or say meaning of this line. This is a extra code, but let me show you the result. This is a function. This is a function blending image. We have to get rid of the blended image. Just show that and just see the result when I will manually change the channels and when I will use the CB2 functions. See, it's showing me the, and one thing, but I explained you before that. See, before using Excel, its shape is, see, its shape is 4 by 4, and after using a level, its shape is 1D. Okay, now see the result of the blended image, the function which we have created. It's working fine. Okay, now one more thing, when I will use this function, the function which is present in a CV2, add weights, which is performing the same mathematical operation on the image, blended 0.5 image. What is the difference in this? Let me show you why I'm manually changing the channels, not using this function. See the result. See first, so see this, the background of this images is not changed, only the segmentation part is changed. But I will, if I will use this function, see, background of the images is dull. See, background of the images is dull. Let me show one image where the white background is there. You will see clear image of that. See the changes. But if I will not use this, and nothing is, just manually change the channels, see the difference. It will only affect the segmented part, not the background of the segmented part. See the brightness of the images. See. Okay, so now we have to load the model. Torch CUDA is available. Give me that which device we are using. Either we are using CPU or a GPU. This is important because the model and images and all things has to be on the same device. Otherwise, it will throw an error. We are using DeepLabV3 ResNet50 with the weights we are using here is default. What is the default is like Coco will be there also, or something else pre-trained. So let me first print the model for better explanation that what I am doing in model classifier and model auxiliary classifier. Let me show you what we are doing. So see, this is a model. This is a classifier part. See, this is a auxiliary classifier, but we do not need this. This is, you can see the extra part. We do not want this in a during training part. We do not need it. Right now, we do not need it, but if you want it, you can use it. Okay. But the process, or you can say the process of using the auxiliary classifier is bit different. You have to add some more lines during training and during losses also. But I do not don't want to use this auxiliary classifier right now for just for the training. Okay. See, this is the last line of a classifier head. It's output channel is 21, means the model pre-trained model is trained on 51 or 21 classes. Okay, but we have only two classes. Why we have only two classes? Because when the model is trained on pre-trained, zero index value is already fixed for the background. So ultimately we have background and then cracks. That's why we have a two classes. So just change the classifier for torch no nn send to 256 is you can say input channel, and output is 252. Why 2? Because here not person, this will be cracks. Okay, now we do not want auxiliary classifier, it should be none. Now let me print the model, final model, and commented this. And models has to pass on a GPU or a key, CPU, the device which we are using. Let me run it now. See the difference. Last layer is changed, and auxiliary classifier name last layer is changed to 256, and 2 here represent number classes which we have. This is a class which we have created, class segmentation dataset. What is the use of this? It's have a data loader to load the dataset. Now this is the initialization of image directory, max directory, and transform. If any data augmentation is there, this basically give me the image file name and the mask image present in a directories. I already told you that when we are using a pre-trained model, zero, we have to include background, and here class. This length will give me how many numbers of images we are using for the training part. See this. First IDs is just for the, you can say, fetching the image file name, all the image file name or a mask image name from the directories. To fetch that, just create a image path, OS path, just pass image directory, master directory, image file name idx, and mask file name image idx. Okay, it will give me the image path and mask path. Read the image, convert into a RGB format. Okay, then image read the mask in a grayscale format, and see what is happening here. It's change all the values present in the mask. If it is greater than 0, it will change to 1, and it will change to 0. Okay, or either 0 or 1. Okay, this way we have to make the mask is suppose any value which is greater than 0, and uh, it is uh, it is not 1. Suppose the mask value is 255 is there, because you can see that mask mostly images is having cracks represented by the white color, means white color means 255 value. But we have to change that. We have to make that 255 value to 1. So we have to use this mask greater than 0 will change to 1, otherwise remains same 0. Now, and data augmentation, apply to data augmentation, we have to pass the self transform images and mask. This variable contain two images, original image and a mask image. We have to access this, or you can say fetch this using this way. Now just return the images and mask data type will be long. Now run it. Now this is a data augmentation which we are using. Pieces we do not we have enough data set for the cracks. We don't use additional data augmentation. Just resize the image and normalization and converting image into tensor. These are the directories. This time, this time we are using a validation directories also, because we have a validation data set also. So give this, create the objects of trained data set and validation data set both. Now pass the parameters according to the constructor or the dot in that bracket init bracket function. Pass the direct parameters, train directory, image directory, and the transformation if any data augmentation is there. Now with the help of data loader, just use the train data set, batch size we want 8, shuffle will true, drop last true. Suppose what is the meaning of drop last true? Is suppose drop last true, because basically it drop the last batch. Okay, it dropped the last batch. Sometimes why we are dropping it, because sometimes the last batch contain only one image, and during training time it will throw an error. Okay, so to avoid that error we can drop the last batch. Okay, we can easily plot the last batch. Okay. And now validation data load, batch size of shuffle is there. For shuffle is false because in during validation we do not run any shuffling because we are just testing the images. Or it's not testing, we are testing the model. We don't need any shuffling is there. Shuffling is required only in a training parts. Okay. The loss which we are using, cross entropy loss, optimizer we are using Adam, and learning rate will be 0.0001. Now see the length, train data load 128, train data set 1508 means 1508 is images is there for the training part, and its batches is 188, and then for the validation we have 187, and its batches is 24 batches is there. Now we will check the val loader. Why we have to use this? Just to see that that mapping of the mask and image is mapping of the mask and image is correct or not. Okay. So number of classes. I already told you what is the meaning of 0.5 transparency. We have a class name VG for the background and cracks for the one class ID. Okay. Random batch index. Now you will get confused that why I'm not accessing this 0.1 slash means giving the color for the background, because there is no need of that, because basically we have to segment beyond. We do not have to segment the background, we have to segment the uh, cracks only. So for the cracks class index is 1, so we have to give that only. It's basically this line basically select batch number uh, batch number from the 0 to the length of the validator -1. Okay. Now till we get the random batch, we will iterate over the val loader. Okay. When we get the val loader, because when you enumerate the val loader you will iterate over till 0 1 2 3. Suppose random batch index is 4, so it will stop where batch idx will be is equal to 4. Now this is the plottation part. What is the use of permute here? Because permute basically when we use a data augmentation or two tensor, it's change the dimension of h image from hwc to chw. But during plotation or using a matplotting, we have to we require hwc formats. So that's why we have to use permute 120 will change the dimension of the image. Now mask ID, we have to fetch the mask mask also. This is a line, just give suppose any value which is greater than, but this time it's not has to be used because we already changed the values here. Okay. But for the safe side, just for the safe side, we are using here. But if you do not use it, nothing is happen, nothing will change. Okay, remain, all things remain same. It's, you can say it's an unnecessary line here. You can remove this. Now this is a you can say this is a function which I had already explained you. Just plottation is there. What is use of this break is that what is use of this break? Because when we reach to our required batch, it will has to we will stop the for loop. Otherwise, if we do not use this break, it will move towards the suppose the random batch size is 4, but val loader length is 128. If suppose we do not require, we will break will not there, it will reach to 5 batch also, 6 batch also, 7 batch also. So to stop the for loop we are using here break. Now let me run this. See the result. Okay, you can see that it's the model is highly the not model images is highly contrast because we are normalizing the pixels value. That's why. Now this is a training part. Well, West loss is infinity. Save model. The model will be saved with the name best model. Train loss list and validation loss list. This now we can use this list, or you can say list for plotation of the protection of the graph. But we didn't. This might be problem because if I will use 20 epochs, So let me first just run for the 10 epoch this time, or you can say 5 epoch, because I already have a weight file which is trained on 50 epoch, but I am training this for the 5 epoch just to show you the how the graph is looking. Okay. Now we are using also LR scheduler cross line here. Where we are passing the optimizer, because optimizer uh, is responsible for updation of the weights. T max will be epochs, ETA mean will be 10 1e 1e minus 6. Uh, Let me explain you what is the meaning of these three parameters. Not three, just two parameters. So here T max representing that after which epoch that learning rate initial value will come. Now one more thing. Initial value of learning rate value will be 0.001 and ETA minimum 1e 1e6. What does mean? Let me show you. First 1e dash 6 mean is this thing. Okay, this thing. Now initial value is 0.001, which we have used above in a code, will get decrease gradually and end up till this 1e 0.06 will end up this, and at after the epochs, after the epoch value only, then initial value will come. Your in one line I can say that from 0.001 the initial learning rate value will start decreasing during training at each epoch, and after end of the epochs, uh, you can say initial value will come up, and its last minimum last learning rate value will be this thing. Now let's get started. Epoch model is a training mode. Epoch training loss will be 0. Just make sure that images and mask will be on the same device. Okay, let me one thing clear it here. Okay, see this float, there is no need of use of float here. Okay, I can directly make sure. Let me run this set and then explain you afterward. It's not defined, I think so. The connection is failed. Yes, I have to run all thing again, so it will run automatically. So let me explain you one by line now in this. So now training mode is the training mode. Now this is a images and marks should be on the same device. What is the use of optimizer zero grade? Optimizer zero grade basically uh, make the gradient value to 0 at each batch iteration. Why we use optimizer zero grade? Because if suppose we do not use it, the gradient value of the previous batch will get accumulated to the current batch, and it will affect the updation of the weights, and this is not good. That's why. Okay, now pass the images and using out you will get when you will I think so it is a output is a dictionary. You will get when you will uh, type out, you will get the output of the predictions, and pass the mask and output to the criteria. It will calculate the loss. Just you loss dot background, where here the calculation of the weights is performed. Optimizer zero step basically update the weights. Now each epoch train loss dot item will give me the loss, and the mod at each iteration of the batch epoch train loss variable loss value will get added to it. After that we have to get the average loss, and after getting the average loss, that we have to append that into a train loss list, and we have to print the masses. Now model is in a for the validation phase. Model is in a model in a evaluation mode. Model now do not update the weights. Now with torch no grid, basically no updation of the weights. Just iterate over the whale dart, fetch the images in mask, image in device will be in the same device, just pass the prediction. Now to for calculator, just pass the output at the mask. Same thing, epoch validation loss, loss value of each bag will get accumulated here. Now just give the average loss. Now print append that in a validation list and print the masses. Now if suppose average loss, validation loss is less than the best loss. Initial best loss we have defined is infinity. If suppose it is less than the best loss, we will change the best loss value and save the model. Scheduler dot step. Now at epochs only, we have to give scheduler dot step. It will make sure that learning rate value will get changed at each epoch. Okay. Now this is a graph part where we will plot the graph of train and validation loss. Figure 10 by 6, plotation, train loss list, label train loss, marker 0. What is the meaning of marker 0? Let me explain you one. Marker 0, what meaning of marker 0 is to emphasize the points of the train loss list and the validation loss list. Okay. Now X label epochs, Y label loss, title, train and validation loss, license is required, grade will be there. Dot show. Now this is a testing tab on an unseen data set. Just load the model using this line, model segmentation, DeepLabV3 ResNet50, pretend false, now classes 2. Okay, now load the weights values. Okay, after loading the weights values, just make sure that it makes device. Now model is in evaluation mode. This is a test directory which contain the images. List all the images present in the test directory. I already explained you these two lines. Alpha, use of alpha, I already explained you. There is a two classes. We do not need a background here, but this time we do not need it. Just for the explanation, I'm showing here that we have a two classes, background cracks and zero stays. Okay, but there is no need of this. Just use cracks and one. Okay, you will get a complete image. Now this is a data augmentation which is performed on the images before training. This all things resize to tensor and normalization. Now images, let me choose random image from that directory. Path, open the image and convert it into RGB. If suppose the image is in a grayscale, convert that into a RGB format. Acquire the data augmentation and squeeze, basically add one dimension, batch dimension in the image, and just pass the input tensor to the model. With torch, no grade means basically model is in evaluation mode and no, there is no updation. Okay. Now to get the output of the first image, you have to use this out with 0. Now we have to get the predicted marks from the output. You have to use torch argument output dimension 0 CPU numpy. Now after that, getting this, we have to convert this image into a numpy, because this in this function and also in this function the images which we use already in a numpy format, so we have to convert this into a numpy format. And image of size, this image basically the image which we have opened using a pill. Okay, it can be the width and height, and according to that height we have to resize this mask, predicted mask, we have to resize it using this original width and height of the image. Okay, interpolation CB2 internear. Suppose there is a empty spaces in empty pixels is there, so we can fill that empty space with the nearest pixels values. Okay, just pass the mask image and class color and just show the image. So I think so 3 epochs is completed. Let's wait for the 5 epoch. Let me come back when this training is completed to show you how the graph look likes. But before that, let me upload the model which is trained on 50 epoch for the testing part. So wait for the minute. Let me pause this. So when the model is trained with epoch 5, see the result, how the graph look like. See, use of this 0 here. If suppose I will not use this 0 here, let me show you the difference. See, the points is not displayed, or we can say visualize. We cannot visualize the points, but suppose I will use this marker 0, it will be, we can see the points. Now when I will uploading my this weight file, which is train of 50 epochs, it might be taking time. So I will use this bass model only, which is trained on 5 epoch. Okay, let me run it. Just I want to show the result. See the result. I think so. The model is working pretty good when it's trained with 5 epoch. Okay, see this. And now you can download this weight file and use anywhere you want. Okay, so I'll explain you each and every line here, and make you feel better at how you can use the image segmentation model and image segmentation dataset. Okay, I explain you each and everything here, and I explain you this part very clearly to you. So if you want more videos like this, please like, share, and subscribe.